Hello. In this video, I'll explain assignment number 5 of solutions. It's a bit lengthy assignment. First numerical. Calculate the mass of oxygen that will dissolve in 9 liters of water at 25 degrees centigrade when the gas is bubbled through it at a pressure of 1.2 bar. Henry's law constant is so and so 33.333 kilobars. There's a value given. So first we'll calculate number of moles of water. This is 9 liters, means 9,000 cc, or I can say 9,000 grams because density of water is 1 gram per cc, or I can say 9,000 divided by 18,500 moles. Now I'll use Henry's law. Henry's law according pressure of the gas 1.2, pH is 33.333 kilobars are converted into bars multiplied by mole fraction of oxygen. Mole fraction of oxygen will be NO2 divided by NO2 divided by moles of water 500. We can neglect number of moles of oxygen in the denominator and calculate. This will come out to 0.018. So weight of oxygen dissolved will be 0.018 multiplied by 32. So many grams of oxygen will dissolve. Second numerical. Calculate partial pressures of A and B and total pressure of the solution in which mole fraction of A is 0.4. Vapor pressures of pure A and B are 100 and 150 millimeters respectively. See, PA will be P naught A into mole fraction 40 millimeters. That is one answer. PB will be P naught B into mole fraction of B will be 1 minus 0.4. That is 0.6, 90 millimeters. And P total or P solution will be this plus this, 130 millimeters. Third, in a solution of volatile liquids A and B, partial vapor pressure of A is 90 millimeters. Calculate mole fraction of B in the solution if vapor pressure of pure A is 120 millimeters. I'll use the relation PA is equal to P naught A into 1 minus chi B. P naught vapor pressure of solution, vapor pressure of A is 90 millimeters. P naught is 120 millimeters. 1 minus chi B. Calculate chi B. This will be the answer. When you calculate, this will be 0.25. Fourth, vapor pressure of a solution containing 1 mole of A and 3 moles of B is 250 millimeters. Vapor pressure increases by 10 millimeters on addition of 1 more mole of A to the solution. Calculate vapor pressures of pure A and B. See, vapor pressure of solution is equal to P naught A into mole fraction of A. Mole fraction of A will be 1 mole and 3 mole, means 1 by 4 plus P naught B. Mole fraction of B will be 3 by 4. This is equation 1. Mole fraction, when 1 more mole of A is added, vapor pressure increases by 10 millimeters. It means it becomes 250 plus 10. When 1 more mole of A is added, mole fraction will be 1 plus X divided by 4 plus X. P naught B into 3 divided by 4 plus X. Right? Because initially it was 1 mole of A, not X, 1 mole has been added. It means it will become 2 by 5, and this will become 3 by 5. Right? Now, this is equation number 2. Now, these are two simultaneous equations. Calculate the value of P naught A and P naught B. Next, fifth numerical. Vapor pressures of pure benzene and toluene are 150 and 50 millimeters respectively. Calculate vapor pressure of the solution prepared by mixing equal masses of the two. Equal masses. Let us see. Say weight of benzene is equal to weight of toluene is equal to X gram. So number of moles of benzene will be 7 X divided by 78. Number of moles of toluene will be X divided by molecular weight 92. From these number of moles, calculate mole fraction. So calculate mole fraction of benzene, that will come out to 0.54. X will cancel out. And mole fraction of toluene will be 1 minus this, that is 0.46. Vapor pressure of solution will be, P naught values are 150 and 50. So 150 into 0.54 plus 50 into 0.46. This will give you the answer, and this will come out to 104 millimeters. Next, numerical number 6. Calculate the mass of benzene that should be added to a solution containing 1 mole of benzene and 2 moles of toluene so as to increase the vapor pressure of solution by 30 millimeters. Vapor pressures of pure benzene and toluene are 150 and 60 millimeters respectively. See. We'll calculate initial vapor pressure of solution. This will be P naught benzene is 150 and initial mole fraction is 1 mole and 2 moles, means 1 by 3, plus P naught toluene into mole fraction of toluene is 2 by 3. This will be 90 millimeters. Now the question is, we want to increase vapor pressure by 30 millimeters. For that, how much benzene should be added? Say, number of moles of benzene added is equal to X. Therefore, new vapor pressure after addition will be 90 plus 30, that is 120, will be equal to P naught will not change. New mole fraction will be 1 plus X divided by 3 plus X. P naught toluene will not change. Mole fraction of toluene will be 2 divided by 3 plus X. Now from this, calculate the value of X. X will come out to 3 moles. It means 3 moles of benzene should be added. Therefore, weight of benzene added will be 3 into molecular weight. So many grams of benzene should be added. Next numerical, 7th. Calculate mole fraction of A in the vapor phase above the solution prepared by mixing 31.2 grams of A and 110.4 grams of B. Vapor pressures of pure A and B are given. These are 80 and 40 millimeters respectively. First, number of moles of A will be 31.2 divided by molecular weight 78. This is 0.4. Number of moles of B will be 110.4 divided by molecular weight 1.2. Now, vapor pressure of solution, that will be P naught is 80 into mole fraction 0.4 divided by total 1.6 plus P naught of toluene is or P naught of B is 40 into mole fraction is 1.2 divided by total 1.6. When you calculate, this will come out to 20 plus 30, that is 50. Remember, partial vapor pressure of A is 20 millimeters, which we'll need in the next calculation. We have to calculate mole fraction of A in the vapor phase, mole fraction of A. So PA is equal to PS into YA. YA, what is YA? YA is mole fraction of A in the vapor state. So mole fraction of A in the vapor state will be PA, that is 20, divided by PS is 50. Answer is 0.4. Eighth numerical. Calculate vapor pressure of the solution containing equal number of molecules of A and B. See, I'll tell you something verbally. When number of molecules is equal, it means number of moles is equal. And when number of moles is equal, then mole fraction of A and B, both the components, will be same. That will be 0.5 each. So that is something you can write in words and tell that mole fraction of both the components is 0.5 each. PS will be P naught 270 into mole fraction plus P naught of the other component 130 into mole fraction. This is the answer. Ninth numerical. Calculate mole fraction of A in a solution of A and B whose total vapor pressure is 115 millimeters. P naught A and P naught B values are given. Now, P solution is 115, P naught A is 160, and we have to calculate mole fraction of A into chi A plus P naught B is 100 into 1 minus chi A. From this, calculate the value of chi A, that will be the answer 0.25. Next, numerical number 10. Vapor pressures of pure liquids A and B are 450 and 700 millimeters respectively. Calculate mole fraction of A in the solution. Solution means in the liquid form and in the vapor phase if total vapor pressure of the solution is 600 millimeters. See, we are given P naught values of both. We are given vapor pressure of solution. It means vapor pressure of solution is equal to P naught A 450 into mole fraction of A plus P naught of B, that is 700, into mole fraction of B will be 1 minus chi A. When you calculate, this will come out to 0.4. This is one answer. Mole fraction of A in the vapor state, this is one answer. Now, PA will be this value, 450 into chi A, 0.4. Now again, PA is equal to vapor pressure of solution into mole fraction of A in the vapor state, and that will be PA 180, vapor pressure of solution 600, answer will be 0.3. So these are two answers. Coming to theoretical questions. First question is, out of 1 molar and 1 molar aqueous solutions of the same solute, which is more concentrated and why? Remember, it is given aqueous solution, means solvent is water. Both have 1 mole of solute. Both have 1 mole of solute in the solution. In this case, it is present in 1000 cc solution. And in the second case, it is present in 1000 grams of water. Now, naturally, 1 mole of solute will also occupy some volume. It means volume of solution, that is volume of water present in the first solution will be less than 100,000 cc, because some volume out of 1000 is occupied by solvent also. So here solvent is less than 1000 cc, or I can say less than 1000 grams, because it is water. In the second case, amount of solute is same, but solvent is 1000 grams. So compare, both have same amount of solute. In the first case, amount of solvent is less than 1000 grams. In the second case, solvent is 1000 grams. That is why first solution is more concentrated than the second solution. Second question to be discussed is, why can't we obtain pure ethanol by fractional distillation of ethanol containing some water? See, ethanol and water, they will form an azeotropic mixture, right? And due to hydrogen bonding between them, they cannot be separated from each other. They distill together as an azeotropic mixture due to hydrogen bonding. So that's all about this assignment number 5.